Hey guys, Sean here for Sean's Capstone Adventure, Episode 7, the final product. In this 7-minute video, I will not have enough time to explain my entire journey, so this video will be more of a recap and reflection and I guess introduction, because I haven't actually explained any of my plans for Capstone or what my Capstone actually is in any of my videos. Now to begin, when Capstone was first announced, I knew I wanted to do some sort of tech project, so I recalled to a video that I watched back in 2015, and I remembered this Japanese tech showcase of a team that developed a machine to like dynamically track an object, or a ping pong ball in this case, and project an image onto the ping pong ball as it was moving. And obviously I remember this and I said, yeah, that's totally doable, so let's do that. And there my Capstone journey began. So my Capstone project aligns pretty well with my career path, right? So I'm pretty interested in coding, and I was the lead programmer on the robotics team, so it makes sense that I'm doing this, right? Yes. So now the main difference between my project and those Japanese tech masterminds is the fact that instead of tracking a ball, I am tracking a face, which is significantly more complex than a round circle with the color of yellow, right? The next difference is my project is on the scale of DIY, and theirs probably costs around $100,000. So the basic premise is I built a camera that follows you around. I'm using a pre-trained model trained by a deep learning AI to recognize the faces at different lighting conditions and different angles. And we're running that through a object detection algorithm. And you might be like, well, isn't that the same thing? Well, no, because the model is pretty much what is looking for, and the algorithm, the object detection algorithm, is how it looks for those objects in the model. And now based on where the object is on the screen, an object IDer and position tracker is applied to differentiate each object, or in this case each face on the screen. Now I have it set to track the face that appeared first, so the lowest object ID, and now using that position we're gonna move stepper motors to rotate the camera on each of its two axes towards the center of the screen. So if it's on the right side of the screen, we're gonna move the camera right, so this object ends up in the center of the screen. Oh yeah, and also it streams all of this to a web page where you can watch it from anywhere in the local network, so you can just open it in a web browser or on your phone. So obviously you can see it's pretty slow, but it is tracking me, and that's all that matters. So my mentor, who is my dad, is a professional coder and has been for the past couple of decades, and he has taught me basic and common practices in organization and project management that are standard in the industry, to which I followed none of because that is way too much effort for a school project. Oh, come on! It's out of the scope of this project! Oh. So here you can see an example of the multiple target thing that I was talking about. So you can see there's only one ID, and that's on my face and not on hers. Now the detection is a bit weird here because she's perpendicular to the screen, but near the end you can see I leave and I thought it wasn't working. I turn off the camera and then it starts tracking her, so That's just unlucky, but yes. So I wanted to take a closer look at this test platform that I've built, right? So over here is the Raspberry Pi. That's pretty much the brains to all of this. It does all the calculations, the object detection, and it tells everything else to do stuff. Here's the camera. I didn't actually attach this, I just put tape. There's the obnoxiously long bundle of cables to the camera. Now here's my 2-axis like servo platform. So this one moves the left right and this one moves the up down. Over here the respective stepper motor drivers to control these things, and they're connected to the Raspberry Pi through a series of jumper cables. And yeah. Now the test platform took like 5 hours to make, and the rest of the code took like 150 hours, but I'm not really sure how to incorporate it into the video, so I'll just go over generalized descriptions of what each part does. So I'll start off with this file called Centroid Tracker in the project, and what it does is it handles the logic for assigning each object an object ID, and also it determines how long an object stays off screen to pretty much deregister that object ID. And then over here is the main project. It does stuff like handle the web page protocol. It does the actual moving based on position with the stepper motors, and it applies the actual model. So I'll just go block by block. So over here, taking the frame after the squares and circles and ID is drawn onto the frame, and over here is the actual logic for the moving of the stepper motors depending on the location. So we have X and Y here, and then over here this main loop here is the actual assigning of the model and turning each image into a set of values pretty much. So how the model works is it works off the contours of an image based on the RGB values. Over here we draw the rectangle, over here we draw the circle, which is the dot, and the text. And over here is the starting each. So each time this runs, it runs the motor logic, and if it wants to run, then it runs, and that's pretty much it. And that's pretty much my Capstone project. If you're interested in looking at the progress or how I got to this point, you can check out the other 6 videos on this topic, but it's kind of like, most of it is just looking at forum posts and bug fixing and figuring out how the code works. But thanks for listening and watching my Capstone final project video, and goodbye. Ooh, look at that, an outro.